All right, so it looks like we're actually going to be moving back to Chapter 8. So this is the stuff that we had done previous to us going on virtual learning. So what we're going to do for this next week, seeing as the week after this is quote-unquote our spring break, we're kind of going to just review everything that we had done on our factoring. Okay, so we're going to take today, Wednesday, Thursday, and Friday, and we're just going to review all of our different factoring methods that we had gone over. And then once we come back from our spring break, we'll then move into our new factoring methods. So the first factoring method that we talked about was factoring using our GCF. Okay, so we had said whenever we have a polynomial, now if we remember, a polynomial is a two or more termed, essentially a two or more termed expression that is being added or subtracted. So something just in the form of like 27y squared plus 18y. This is a polynomial, and more specifically, this is a binomial, because if we remember, binomial is any two-termed polynomial, and this has two terms. A three-termed polynomial we called a trinomial, and then a one-termed polynomial we called a monomial, and then anything other than three we just called a polynomial, or a four-termed polynomial, or a five-termed polynomial. So whenever we look to factor something, if we remember correctly, the first method that we always try, no matter what polynomial we have, is GCF. And again, GCF stands for greatest common factor. So we are going to look to pull out the greatest common factor. So in order to do that, we take a look at both of my terms. We're going to start by looking at the coefficients. So in this case, we have a coefficient of 27 and a coefficient of 18. So what I want to do is I want to look at all of the factors of each of these numbers. So 27 has a couple different factors. It has a factor of 3, it has a factor of 9, it has a factor of 27, obviously, it has a factor of 1. Those are the only factors that we have of 27. 18 also has a couple factors. We have 1. We'll start off with 1. We have 2. We have 9. We have 18. We have 3. And we have 6. So 18 has a couple more factors than 27, obviously. So what we now do is we look for the greatest number that is both a factor of 27 and 18. So in common, they obviously have 1. We don't usually look at 1, but we'll look at it for this case. They have 3, and they have 9. Those are all their common factors. Well, we now look for whichever one of these is the greatest, and we see that 9 is the greatest common factor between 18 and 27. So whenever we factor using our GCF, what's going to happen is out front we're going to have the GCF, whatever that may be, and then on the inside we're going to have whatever is left. So we'll call this our factor, and then plus or minus, whatever the sign is, plus our other factor. So here, seeing as we started with this, we now know that the part of our GCF is going to be 9. That's the part that is the greatest common factor between each of the coefficients. Okay, once I get the coefficients done, now I want to move on to the variables. So what I do with the variables is first, I look to see if I have a variable in all of my terms. See how this y is in all of my terms here? I see a y in the first term. I see a y in the second term. Because the y is in all the terms, that means that I am able to factor it out. I don't know what I'm going to factor out yet, but I can factor it out. If the specific variable we're looking at is not in all of your terms, it cannot be a part of the GCF. So I wouldn't worry about it in terms of putting it into the GCF. But since the y is here in both terms, now I'm going to say, okay, I need to find the greatest common factor between y squared and y. Well, it's very simple with our variables. To find the greatest common factor of the variables, you look at your variables and you say which one of these has the smallest exponent. This has an exponent of 2. This has an exponent of 1. So the smallest exponent is y to the first. This is what we are going to put in the GCF. We would put y to the first or just y as my GCF. That's how we get the GCF. You start with the coefficients, find the GCF of the coefficients, then you move on to the variables, see is the variable contained in all of the terms? If it is, you're taking the smallest exponent. If it's not included in all the terms, it can't be included in the GCF. So now we have to put what's left. We have to put these factors that are left. So now that I have the 9y out front, I now need to figure out what's left inside. Well, the easiest way to figure out what is left inside, we haven't used orange yet, is to take each term and divide it by what we just got as the GCF. So I'm going to divide each term by 9y. So 27y squared divided by 9y, well, 27 divided by 9, that's going to give us a 3. And then y squared divided by y. If we remember back when we are dividing variables that are the same variable, we take the exponents and we subtract them. So 2 minus 1 gives me 1. So this is going to be y to the first, or just y. Then whatever my sign is, I copy that right here. And I do the same thing for the next term. 18 divided by 9, that's going to give me a 2. Y divided by y, those are going to cancel each other out. So I'm just left with 3y plus 2. So my final answer, my final factored form, is going to be 9y times 3y plus 2. That would be my final answer. All right, let's try one more. Let's say that we wanted to find the factored version of negative 4a squared b minus 8ab squared plus 2ab. So here again, seeing as I'm looking to factor first by using my GCF, I start by looking at my coefficients. So I say, all right, I have a negative 4, I have an 8, and a 2. So the factors of each of these, well, the factors of 4, that's going to be 1, 2, and 4. The factors of 8, that's going to be 1, 2, 4, and 8. And the factors of 2 are going to be 1 and 2. So out of all of my common factors, which is the greatest between all three of them? Well, they have a 1 in common, all of them. And they have a 2 in common, all of them. So the greatest common factor between all three is going to be 2. So this 2 comes out front. Now I'm going to look at my variables. The first term has an a, the second term has an a, the third term has an a. So I get to work with a. So I say, all right, out of these a's, which of these has the smallest exponent? Well, this has an exponent of 2, this has an exponent of 1, and that has an exponent of 1. So, obviously, the smallest exponent is 1. So, I'm going to take out front an a to the first, or just an a. I'm going to do the same thing with b. This term has a b, this term has a b, this term has a b. So again, I'm looking at my exponents. This has an exponent of 1, this has an exponent of 2, this has an exponent of 1. I'm going to take whichever one is the smallest, and obviously, exponent of 1 is the smallest, so I'm taking a b out front. Now that I have everything out front that I need, I'm going to take this GCF and divide it by every single term. So I'm going to take 4ab divided by 2ab, or sorry, negative 4a squared b divided by 2ab. I'm going to take 8ab squared divided by 2ab. I'm going to take 2ab divided by 2ab. So for the first one, we have negative 4 divided by 2. That's going to give us negative 2. We have a squared divided by a. I subtract the exponents. 2 minus 1 gives me 1, so it's a to the first, or just a. I have b divided by b. Those are going to cancel each other out, so I'm left with just negative 2a. I bring the sign down. Since this is a minus sign, I'm going to bring the minus sign down. 8 divided by 2, that's going to give me 4. A divided by a, those will cancel out. B squared divided by b, subtract the exponents, 2 minus 1, that gives me b to the first, or just b, and that's it. Take the plus, bring it down. 2 divided by 2 is 1. A divided by a cancels out. B divided by b cancels out, so I'm left with just 1. Remember, whenever you have the same thing on top and on bottom, you are always left with a 1. So this here would be my final answer. 2ab times negative 2a minus 4b plus 1. Alright, so there's 3 problems here on the whiteboard that I would like you to try on your own. So hopefully from our previous knowledge and from re-going over this right now, we should be able to factor these polynomials with no problem. But pause it here, take about 5 minutes, try these on your own. So here are my 3 answers. For the first one, we have a GCF of just 3. 15 and 3, the only common fact that they have is 3, other than 1, so that is the greatest common factor. Now, w is not in both of them, so I can't factor out a w, and v is not in both of them, so I can't factor out a v either. So I just don't factor any variable out. My GCF is just 3. So then I take each of my terms, divide it by 3, 15w divided by 3, 15 divided by 3 is 5, w divided by nothing is just w. 3 divided by 3 is 1. I don't have to put the 1 coefficient. V over nothing is just v. For the second one, for my coefficients, I have 7, 21, and 1. Well, whenever I have a coefficient of 1, that means that you cannot have any other factors other than 1 be a factor of 1. So the only factor that they have in common will be 1, and we don't pull a 1 out. So if you ever see a coefficient of 1, you know that you can't pull out any number. There is no greatest common factor for the coefficients, so I don't worry about it. But then I move on to the variables, and I see that they all have a u. I look at the exponents, which is the smallest exponent. It's a 1, so that's why I pull the u out. T squared, and t, they all have a t, which is the smallest exponent. Again, it's 1, so I pull out a t. Now I'm going to take them all, divide it by ut. 7 divided by 1 is just 7. U squared divided by u. Subtract the exponents. You get 1, or just u. Same with the t. 2 minus 1 gives you 1, or just t. Sorry. Caught a mistake on my own here. This should not be 3. This should be 21. So let's fix that here. Not 3. This should be a 21, because 21 divided by 1 is just 21. I'm not really sure where I got my 3 from there. Anyway, u divided by u, that's going to cancel out, and t squared divided by t is going to be 2 minus 1, which gives us a 1, so it's t to the first. And then here, ut divided by ut, like I said before, same thing on top and on bottom. They're going to cancel out, and it's just going to leave you with a 1. Over here, 16t minus 40y, again, the coefficients, the greatest common factor between 16 and 40 is 8. But this has a t, this doesn't have a t, so I can't pull a t out. This has a y, this doesn't have a y, so I can't pull a y out, so the only GCF is just 8. So then I go and divide everything by 8. 16 divided by 8 gives us 2. T divided by nothing is just t, so it stays. 40 divided by 8 gives us 5. Y divided by nothing is just y. So again, that was our first method of factoring, GCF. Our second method of factoring was called factoring by grouping. Now, factoring by grouping was only done in one specific situation, when we had a 4-termed polynomial. We only factor by grouping when we have a 4-termed polynomial, meaning when we have something, excuse me, something like 4qr plus 8r plus 3q plus 6. So here we obviously have a 4-termed polynomial. There's 4 terms here, 1, 2, 3, and 4. So when we have a 4-term polynomial, we look to factor by grouping. Now what I will say, though, is the first thing I should always check to do is look to GCF. If you can GCF here, you should GCF first. But when I look at it, 4, 8, 3, and 6, none of them have a greatest common factor between all 4. This has a q, but this doesn't, so I can't factor out a q. This has an r, but this doesn't, so I can't factor out an r. So this has no GCF to it, but it needs to be checked first. GCF should always be checked. Okay, and that'll come into play a little bit later on, probably once we get to after our spring break, supposed spring break, whatever you want to call it. We're going to be working with a lot of taking a GCF out first and then having to factor it more, having to factor it again. All right, but in this case, we don't have to. So, factoring by grouping says, when I have a 4-termed polynomial, I'm going to take my first 2 terms and I'm going to group them together. I'm going to put parentheses around them and work with them separately. Then I'm going to take my second 2 and I'm going to group those together as well. Make sure you're including this sign with this term, because remember, the sign goes with the term. So like this is a positive 8r, this is a positive 3q. Obviously there's no sign here, but because there's no sign, it's a plus. This is a positive 4qr, this is a positive 6. The sign in front dictates whether it's positive or negative, so it's important to keep that sign. So first step, group the 2 together. Group the first 2 together, group the second 2 together. Now, step 2, we're going to take each of these groupings and we're going to kind of work with them separately. So I'm going to take the 4qr plus 8r, and I'm going to work with this as like a separate equation. And I'm going to say, okay, is there a GCF between 4qr and 8r? Now the answer to that question is yes. 4 and 8 have a common factor of 4. So I factor out a 4. The first term has a q, but the second term doesn't, so I don't factor out a q. The first term has an r, and the second term has an r. They both have an exponent of 1, so I'm going to factor out an r to the first. Now I'm going to figure out what is left. 4qr divided by 4r, that's going to leave me with just q. 8r divided by 4r, that's going to leave me with plus 2. And I took the plus from whatever the sign was there. So that's going to be the factored out version of the first one. Now let's take a look at the second one. We're going to do the same thing. Now, I don't need to put plus 3q because, again, like I said, that this just means that it's positive. So it's a 3q plus 6. And I'm going to do the same thing here. I'm going to factor out my GCF. So I look at the 3 and the 6, and I say, well, the greatest common factor between 3 and 6 is 3. The first term has a q. The second term does not. So it's just 3. I can't factor anything else out other than 3. So 3q divided by 3, that's going to leave me with a q. 6 divided by 3, that's going to leave me with plus 2. All right, so now we move on to step 3. Well, step 3 says, okay, now that I have GCF'd everything out, I have to look at this. And I have to say, well, is my parenthesis exactly the same? Now, in this case, it is. Q plus 2, Q plus 2. If that's the case, then we can factor this by grouping. If those were not the same, we wouldn't be able to factor by grouping, or maybe we didn't GCF correctly. Maybe we have to pull something else out. Okay? So you'd want to go back, you'd want to check, make sure that you GCF'd everything out. But if you know you did, and you still see that these two parentheses are different, then it can't be factored, or we call it prime. But here we have a twin. So what I'm going to do is I'm going to take that q plus 2, and that is going to be part of my answer. That's the second part of my answer. First part, it really doesn't matter in which order we put it in. But this is going to be part of my answer. Then I take a look at the two GCFs that I pulled out, a 4r and a 3. I'm going to take those two, and I'm going to put them in their own parenthesis. So it's going to be 4r, and this is going to be plus 3 because this is a positive 3. So my final factored out version is going to be 4r plus 3, q plus 2. Now again, I can always check this by double distributing. If I double distribute this, do I end up with what I started with? Well, again, the question in this case is, yes, I do. 4r times q is 4qr. 4r times 2 is 8r. 3 times q is 3q. 3 times 2 is 6. And I do end up exactly with what I started with. So I know that I factored this out correctly. You should always be checking your work when factoring. It makes it very simple to check. Okay, so let's try another one here. So here I have 2mk minus 12m plus 42 minus 7k. Again, I should always look to see, can I GCF anything out? 2, 12, 42, and 7, well, no, unfortunately, they don't have any common factors. I don't have an m in every term, and I don't have a k in every term, so there is no GCF for the entire polynomial, so I don't have to worry about that. But I do see that I have a 4-termed polynomial here. So I am going to look to factor this by grouping. I'm going to group the first two together, and I'm going to group the second two together. I'm going to take my first parenthesis, I'm going to work with this separately. So I'm going to say, okay, 2 and 12. What is the GCF between 2 and 12? Well, the GCF between 2 and 12 is 2. Then I look at the variables. I've got an m here, I've got an m here. I see that both terms have an m, both to the first power, so I pull an m out. I see a k in the first term, but no k in the second term, so I can't pull that out as a GCF, so my GCF is just 2m. Now I take each of my two terms, divide it by 2m, 2mk divided by 2m, that's going to give us just k. Minus, because it's a minus sign here, 12m divided by 2m, 12 divided by 2 gives me 6, m divided by m, they cancel out, so it's just k minus 6. So that's what I have for the first one. Do the same thing for the second one, 42 and 7. Well, they have a common factor of 7, the greatest common factor of 7. The first term doesn't have a k, the second term does, so I can't pull the k out, so it is just 7. So 42 divided by 7, that's going to give me 6, minus 7k divided by 7, that's going to give me k. But now I run into a bit of an issue here. Here I see k minus 6. Here I see 6 minus k. They're very similar, but they're not exactly the same. They need to be exactly the same in order for us to use this as our twin or use this in my answer. So if I see this, if I see that my two parentheses are almost identical, in this case, the only issue here is that this k is negative. Let me put it here. This k here, this is a negative k, and this is a positive k. This is a negative 6, and this is a positive 6. So if the only issue is that the signs are different, the signs are a little off, one is positive, one is negative, one is positive, one is negative, then what I'm able to do is I can take this entire second equation, or first equation, it doesn't really matter which one, and I can take it and I can multiply it by negative 1. I can take the entire thing and multiply it by negative 1. So what that means is that this 7 becomes a negative 7. This 6 becomes a negative 6, and the k becomes a positive k. So what I'm actually going to do here is I'm going to put the k in front. Because it's a positive k, I like to have positive things in front there. And since the 6 is negative, I'm going to put it as a minus 6 in back. And now, we see that they are exactly the same. So if you ever run into that issue where both of your parentheses are almost identical, just the signs are different, you can take one of your two things and just multiply it by a negative 1. So now I can say, all right, I have the two twins. In one parenthesis, I'm going to put k minus 6. In the other parenthesis, I'm going to take my GCFs of 2m and negative 7, and it's going to be 2m minus 7, because it's negative. And that is going to be my final answer, 2m minus 7, k minus 6. Alright, so again, we have two problems up here on the whiteboard. I'd like you to pause the video here, take about 5 minutes, try and factor these. Now, I will give you a hint. You cannot GCF anything out of the entire polynomial. So I'm allowing you to skip that first step of trying to GCF anything out if you can. So there is no GCF between this entire polynomial. There is no GCF between this entire polynomial. So skip right to factoring by grouping, because we see that both of them have 4 terms. So there's your little hint. See if you can do this. Pause the video here, take about 5 minutes. So here are my answers here. For the first one, if you realize this, if you see here how we grouped our first two together, grouped our second two together, the first one wasn't a problem. 3 and 15 have a greatest common factor of 3. They both have a p, so I take out the p. I'm left with n plus 5. That one shouldn't be too much of an issue. But for the second one, what I did here was I factored out a negative 4. So here's again a little tip. If you see that both your first and your second term are both negative, it's probably a good idea to factor out a negative whatever your GCF is. Because what that's going to do is it's going to make both of the numbers positive on the inside of the parentheses. So it may save you a step. It may save you from having to multiply the entire thing by negative 1 later on. But if you multiplied it by negative 1, not a big deal. So here I decided that I was going to factor out a negative 4. So this is going to become positive n. This is going to become positive 5. And now I see that both of them have n plus 5 as the one parenthesis. And I take the 3p minus 4 and I put it in its own. Over here, same concept. 3p minus 2p squared has a p as a common factor. So I'm left with 3 minus 2p. Here, I see that both terms aren't negative, so I only factor out a 9. Remember, I said the trick here was if both of these are negative, to factor out a negative number. If they're both not negative, you may just want to factor out a positive number. If you factor out a negative, it's not a big deal. You'll just have to, again, multiply by negative 1 later. So I factor out just a positive 9, and I'm left with negative 2p plus 3. Now, you may be asking yourself, well, wait a second, Mr. Kelly here. 3 minus 2p and negative 2 plus 3, those aren't identical. Well, they are. Because remember, I can just rearrange terms. This minus 2p is a negative 2p. This is a negative 2p. This is a positive 3. This is a positive 3. I can just move them around. I can say, all right, instead of 3 minus 2p, I could have negative 2p plus 3. They're exactly the same thing. Same with this. Negative 2p plus 3. That's the same as saying 3 minus 2p. I'm just moving the terms around. I'm not changing the sign, right? The negative 2p, it's still negative 2p. This 3 is still a positive 3. I'm not changing the numbers. I'm just rearranging where they are. It's the same as if I said 2 minus 4. We know that that's negative 2. It's the same as saying negative 4 plus 2. They both equal negative 2. It's not going to change the value. I'm just rearranging the numbers. So that's why we can do that with that. So as we see, that is our twin there, 3 minus 2p, so I put that there. And then p plus 9 is my GCFs.